Okay, so our next example, we're looking at the equation and we're trying to find where the function is discontinuous and we're trying to find the limit as x approaches that value where it's discontinuous. And so notice we have a rational function, and so we need to be careful. It's undefined on values which set our denominator equals 0. And so we need to find values of x that set our denominator equals 0. Well, if it wasn't factored already, I would have to factor it. And so we want to look at, when is 2x plus 1 all times 3x plus 6? When is this equal to 0? So since it's already factored and it's set equal to 0, we can just set each piece equal to 0 and solve for x. So we're looking at when is 2x plus 1 equal to 0 and when is 3x plus 6 equal to 0. So looking at the type of equation, this is linear. So I isolate my variable on one side, get everything else on the other. So moving terms that don't have the x, I would subtract 1 on both sides. I get 2x equals -1. And then get rid of the 2 in front of the x. We divide both sides by 2. I get x equals -1/2. So solving for x in the equation 3x plus 6, let's isolate our variable. So moving the 6 over to the other side, we would be subtracting 6 to both sides. We get 3x equals -6. Divides both sides by our 3, we get x equals -2. Okay, so there's two places where it's undefined, it's not in our domain, so that means there has to be some sort of something's happening at that value or those values. So discontinuous. X equals -1/2 and x equals -2. So we want to look at the limit as x is approaching those values. Looking at the limit as x is approaching those values. Let's first look at the left-hand side. So let's look at -1/2. Actually, let's look at -2 first. So let's look at -2 approaching on the left of this -2x all over 2x plus 1, 3x plus 6. So recall we have an asymptote here, a vertical asymptote. And so this graph is either going to be shooting upwards or downwards to positive or negative infinity. And we need to figure out which direction. So I know I have a vertical asymptote there. If I plug in numbers to the left of -2, so these would be numbers that were x values smaller than -2. Let's kind of see what type of number are we getting back? Are we getting back a positive number or a negative number? Let's kind of think about it. If I plug in a negative number and I multiply it by this -2 in the numerator, so -2 times some negative number, that's actually positive. So my numerator would end up being a positive number all over. Okay, so let's think about it this way. If I plug in a number less than -2 in for this piece, so 2 times a number smaller than -2, so maybe -3. So 2 times -3 is -6 plus 1. That piece is negative. Any number I plug in for x, it's always going to be negative to the left of -2. So that first piece is negative. And then if I again plug in a number less than -2, if I plug in -2, that's what makes it 0. But if I plug in, let's say, -3, that's -9 plus 6, that's negative. If I plug in -4, that's still going to be negative. And so it's negative here also. And so using rules of multiplication, multiplying two negatives together is positive. And so if we have a positive number over a positive number, that's positive. So right now, graphically, I know what's happening on the left of x equals -2. It's going to be shooting upwards. And so that limit is going to positive infinity. Where if I looked at it coming in on the right-hand side, so we're going to do something similar. Of this equation, so -2x all over 2x plus 1 all times 3x plus 6. And we kind of think about the reasoning behind it again. Well, if I'm putting a number to the right of -2, so like -1.9, -1.99, and I'm put it in here and I multiply that by -2, I notice my numerator still is positive. But if I put in a number here, so again, -1.5, well, 2 times -1.5, that's -3 plus 1. That's still negative. It's going to be negative for that first parentheses. And if I plug in a number here, though, -2 is not going to work. But if I do 3 times, how about, let's say, -1.5? That gives me back -4.5 plus 6, which is a positive number. You can try in the calculator if I plug in -1.99 plus 6, that gives me 0.03. It's positive. So anything I plug in on the right of -2, close to it, is going to give me a positive number for this piece. And so positive, negative times positive is negative. Division, 1 positive, 1 negative is negative. So this is equal to negative infinity. Don't do that. So now graphically, this is coming downwards as x is approaching -2 on the left. And the limit as x approaches a, well, we know it's discontinuous. -2 in this case. And it doesn't exist. Left and right hand are not the same, but they're not even going to one y value. It does not exist. Does not go to one y value. So we would do the same kind of reasoning for the other value, x equals -1/2. So if I was to look at the limit as x is approaching -1/2 from the left-hand side, and it's -2x all over 2x plus 1, 3x plus 6. So if I plug a negative number in here for x, that's a negative in the numerator, all over. So something to the left of -1/2, so -5.5. If we plug that in there, is that number going to be positive or negative? Well, if I do 2 times negative 0.55, and I add it to 1 there, I get negative 0.01. So I notice that's going to be negative on the left-hand side. And negative 1/2 though, or close to negative 1/2 times 3, that's like negative 1.5. Adding that to 6 is going to be positive. So we get negative over negative, which is positive. So as we're getting closer and closer to negative 1/2, it's shooting upwards. Just so we kind of blow it up a little bit. This is negative 2. Let's say that this was negative 1/2 here. And on the left, we said it was going to positive infinity. So somewhere in here, something's wrong. That would be going upwards. I'm just thinking that something's wrong because I know that just mathematically, in order for this to happen and come back up and go like this would be crossing my x-axis. And I know looking at this, I can actually tell where it's crossing my x-axis, and that is at x equals 0 and not at in between negative 2 and negative 1/2. So let me just kind of think about this for a second and relook at my work. Okay, so what I did wrong, negative 2 times a negative number, this should have been positive. And then a positive over a negative is negative. And so I was right, it couldn't cross the axis there, x-axis there. It kind of turns around somewhere in here, and it's going to be going downwards. So we're going to actually have tools later on in this course where we can find where that direction is changing. We can find where things are increasing, decreasing, and the rate at what they're changing. And then one other one would be the limit as x is approaching on the right-hand side of negative 1/2. Well, negative 2 times a negative number is also positive. 2x plus 1, if you plug in a number like negative 0.49, so 2 times negative 0.49, something coming in the right of negative 1/2, plus 1, that gives us a positive number. And then if you plug in 3 times something near negative 1/2 and add it to 6, this is also positive. So this would be going up to positive infinity. Okay, so I kind of gave you a picture of what's going on with the graph by a little bit of what's happening at those values by knowing what this is, what is going on. And we're not going to any one y value, so that limit of that function does not exist.